go live first.
And now you've got yourself something funky.
Oh, I didn't connect. 1 second. Okay.
Is not good for me. That is not good for me.
Nope. Wrong thing. It's like I'm new at this. I mean, I am kind of new. Let me double check that everything's working properly. Okay. The live on LinkedIn works. YouTube. Working. Yeah. Let me double check that everything. Okay. Perfect. Hello. What's up, everybody? Live like a little bit early. I posted on Instagram like I normally post right on time at 2, and I clicked the post story button like 5 minutes early, so here I am. Welcome. We're here another day. Once again, I'm streaming a little bit earlier this week, just to try it out, see if the schedule works best for me. But yeah, if you've seen the description of on the video, or like maybe you just clicked off of Instagram, I can explain a little bit of what we're doing today. Last week I worked live on building a load balancer. And I think most of if not all of the features are done. I just need to like thoroughly test them. And then I'm gonna try and publish the package, like the modules, the Go modules today. See if I have time to do both of these. But yeah, today we're gonna keep working on that like Go load balancer project. Like I ran over a little bit over like what a load balancer is and how it works and the algorithms that I was using. But once again, if you have any questions as we're going along, I'd be happy to just like stop and pull out a little paint whiteboard and start explaining. It's not too complicated, but just it's not something like a lot of people know about load balancers and how important they are in today's like web infrastructure. So today we're gonna keep working on that. But first of all, I'll just address a few things. First of all, my background right here. Let's see if I can move out of the way. I'll just move my camera. There we go. My background right here. Does anybody know what this is referencing? This is from the movie Fight Club. When was the release of Fight Club? 1 second. Fight Club. Oh, it released in 1999. If you haven't seen Fight Club, go watch it today, especially at least here in Canada. I don't know about other places in the world. It's a good day to like start watching Fight Club if you haven't already, because they did a re-release of the 1999 movie, but they remastered it in 4K, and I'm gonna go watch it today with a friend that has never watched it, so that should be pretty interesting. I don't know how much he knows about it or if he's heard anything about like the movie in general. I don't want to talk too much about it because I don't want to spoil things. But yeah, if you haven't watched Fight Club and it's in your movie theater nearby, go watch it. Go watch the remaster. I think it's a really good movie. But yeah, so yeah, today we're gonna just do the load balancer thing. But first of all, I'll do the Lorcana card of the day. Actually, one thing that has happened recently is the like the new set. There's a new set coming out in Lorcana, and it's gonna have the characters from Toy Story and the characters from The Incredibles, and I'm really excited about it. I think all of the characters and everything should already be up here. Let's see, Wilds Unknown. Yeah, so these are all of the new cards that are coming out, and let me just sort them by, or like the ones that they've announced. I don't know, I don't think this is all of the cards. Yeah, because there should be at least 204, there's 158. So they haven't shown all of the cards, but these are the ones that they've announced so far. So they're right here. I don't know if they'll be in the bucket that I used. Let's see. Let's see if we go here to set, this should be set 12, right? Yep, set 12. And then let's go to 001 maybe? Or maybe it's just 1? I'm not sure. No. I don't think they'll be up here yet. Maybe let's look at one of the cards that have been announced. 38. Or let's look at a high number. 147. Let's try that. Okay, so no, we don't have any new cards up here on like the bucket where I get the images from with my program. So I'll actually like start using these cards once the new set releases. Is the music too loud? Maybe. I'll just maybe lower down the music. So we'll include these cards once the set releases, and I have them I have access to them on the bucket that I use to like pull out the images. But for now, we'll just keep using the first 11 sets for the Lorcana card of the day. And talking about the Lorcana card of the day, let's run the program. Ooh, okay. Alan A. Dale. I have a lot to talk about for this one. Well, not a lot, but I have a decent chunk. So Alan A. Dale, it's a 4-cost Inkable. Inkable, once again, is this, if it has this little circle, like golden circle around the number, it means it's Inkable. If it doesn't, it's not. And Inkable means that you can add it to your resource pool, because you can use cards and you can put them in your resource pool to use them to pay for costs. So it's an Inkable 4-cost called Alan A. Dale Rockin' Rooster. It's a 2 strength, 3 willpower. It has an ability, it's a Storyborn ally, and it has an ability called Fan Favorite. Whenever you play a song, gain 1 lore. Now that's gonna come in place in like a second. I'm gonna explain why. It quests for 2 lore. It was done by the artist John Lauren. It's card 20 out of 204 of set 5, so it's rotating out soon. And once again, set rotation is a thing they do for like these trading card games, where they'll like take out of like the competitive pool of cards that you can use. They'll take out like an amount of sets so that you can like have like a fresh metagame. Because otherwise, there's like maybe some like really powerful cards from like earlier sets that are just like very like competitive and like, people keep using them. So they want to like to keep the metagame fresh. They want to just rotate out old cards, put in new ones, and keep the metagame healthy. And we're coming into it. So we're on set 12. Set 12 is coming out in May, and set 12 is going to be the last set before rotation. And set 13, the sets 5, 6, 7, and 8 are going to rotate out. And we're only going to have 9, 10, 11, 12, and 13. Because sets 1 to 4 have already rotated out. But once set 13 comes out, sets 5 through 8 are also going to rotate out. So that'll be interesting. We're on the last part before rotation. But coming back to Alan A. Dale, and also this is a character from, I don't know, movie character from Robin Hood. I need to watch Robin Hood. I've watched all of like the live action ones or whatever, but I haven't watched the animated one, I don't think. And the special part to pay attention here is whenever you play a song, gain 1 lore, and that comes into play with the Monstro Infinite combo Lorcana. And let's pull up the images. Let's see. Okay, yeah, so it's right here. And so for this combo, Alan A. Dale is a critical part of it, and you need these 4 cards. And it's a combo that allows you to win the game in 1 turn. I mean, obviously not in 1 turn, because you still need to get to 8 ink and play these. But once you get all of these characters in play, you can win the game automatically. Or like get these 3 characters and also get this action. So the way it works is you play Donald Duck, and it's this Donald Duck right here. It says for each item named the nephew's piggy bank you have in your play, you pay 2 less to play this character. When you play this character, your other characters gain exert to draw a card this turn. So only that second effect is going to be important. So when you play this Donald, all of your other characters that you have in play at the moment gain that when you exert them, when you turn them sideways, you can draw a card. You can turn them sideways to draw a card. Then so you play that to give your other characters exert to draw a card. Then Monstro, you have Monstro, this other card that says you can choose and discard a card. Ready this character. He can't quest for the rest of the turn. So that Monstro lets you discard a card to ready him, and you can use Donald's effect again to go through your deck quickly. So how it's gonna happen is you have both of these in play, the Donald Duck and the Monstro, and then you exert Monstro to draw a card, and then you discard a card to ready it again, and you exert Monstro to draw a card, and you discard a card to ready it again, and that's not once per turn. And you keep doing that until you go through your whole deck and you get the cards that you want in hand. Once you run through your whole deck, like you don't have any more cards to draw, you play Alan A. Dale, this character right here, that says the Lorcana card of the day. You play it, and then you discard one copy. Each time you sing the song, okay, so you play the Alan A. Dale and you keep 2 copies of We Know the Way in your hand. Each time you sing the song, you gain 1 lore from Alan A. Dale, because it says whenever you play a song, gain 1 lore. You discard 1 copy with Monstro, and then you use We Know the Way to put it back into your deck and hit the second copy from the top of your deck. If you do, play it for free and keep the loop going. Repeat until you reach 20 lore. So, We Know the Way, it's the only card we haven't talked about yet. And it says, you can shuffle a chosen card from your discard into your deck. Reveal the top card of your deck. If it has the same name as the chosen card, you may play the revealed card for free. Otherwise, put it into your hand. So you you play. Okay. If it has the same, reveal the top card of your deck. If it has the same name as the chosen card. Play the card for free. Okay, I don't know why we need the second copy. Then use it. We Know the Way to put it back into your deck and hit the second copy from the top of your deck. If you do, play for free and keep the loop going. Okay, so what it does basically is like you have the We Know the Way. You play We Know the Way. And then you're allowed to put one of your We Know the Ways. Oh, that's why you need the second copy, because you need to discard. Right. So with Monstro, you sing, like with Monstro, you discard 1 We Know the Way and put it in your discard. Then you sing this card with Monstro, right? And that allows you to shuffle your other We Know the Way into your deck. And then you can reveal the top card, which is going to be that We Know the Way, because you only have 1 card in your deck. So you're going to reveal that, and it's going to be the same one as the one you had in your discard, so you're going to be able to play it for free. And then you have the other card in your discard, and then you can keep cycling, and you sing these songs like infinitely until you gain 20 lore with Alan A. Dale. So that's like, it's an infinite combo people came up with like a long time ago, I think when Monster came out in set 8. And like it's not very popular because it's obviously it's hard to pull off. Like you need 2 8-cost characters in play at the same time, and so you're gonna need 8 ink. This is normally for like purple yellow, it's gonna take you 8 turns to amass like 8 ink to be able to play, and then it's gonna take you 2 turns to play the Monstro and then the Donald Duck, unless you get it for like cheaper if you have the Nephews Piggy Bank, and then you need to play an Alan A. Dale. And then you can do the combo. So it's going to take a long time, and if you're playing against an aggro deck that can quest very fast at the beginning of the game, you're not going to get to this point where you're going to have 8 ink and going to be able to pull off this whole combo. But if you do, then you win automatically. So pretty interesting Lorcana card of the day. Let's read the flavor text. It says, "Thank you. Now here's a little ditty for Floodburn friends that we call Martin and the Flood." Look at that. It says Martin. That's my name. And it's an uncommon. So yeah, what kind of card of the day for you guys? Okay, so back to the little balancer, I guess. For those of you who were in like yesterday's stream, I uploaded the solutions for the lead code questions that we did yesterday. I just had to like add some explanations with comments at the top. But the explanation should all be up on the GitHub, like github.com /agentbot/lead should be. Okay, and let me open a couple more windows because I feel like we're gonna need them. Do that. Do that. Copy this. Alrighty. Okay, so last thing we did, just for like a refresher. Okay, yeah, that makes sense. Just for a refresher of what we did last time. Let me just go into my load balancer thing. Okay, now we can open it. We created these two files, so leastconnections.go and resourcebase.go, that are pretty similar. They're just algorithms for our load balancer to figure out which server should be sent the next request to. And it does it in a dynamic way, so that means what it means is like in round robin, it's a static way of figuring out who the next server that should be sent it to is, where it's like it just does it like it just sends it to the next one. It just sends them in order, so it does 1 2 3 4 5 1 2 3 4 5. Or in the weighted round robin, it would send more requests to specific servers that you've indicated beforehand that should have more weight. For the least connections and resource based, what they do is basically send the connection to the server that is the least overwhelmed or the least busy. So you have your servers right here. Let's say you have these 4 servers, and then this is your load balancer, and you're receiving requests from your app, right? And so you have to decide between these 4 servers which one you should send it to. So for least connections, these servers are going to have a count of connections. So we're going to call it con. And let's say this server 1 has 4 open connections at this point in time. This server right here has 7 open connections. This server right here has 2 open connections, and this server right here has 15 open connections. Like this is a very it's a very popular app. You're getting a lot of simultaneous connections. Or very slow maybe. It just takes a while to like respond to the requests. And so what this load balancer is going to do is it's going to take a look at the amount of connections for each server, and it's going to send the next request to the server that has the least connections. So in this case, the server that has the least connections is this one, because it has only 2 connections. That's the least amount of connections. So the next request is going to go to here. Now the server might have 3 open connections at the same time. You receive another request, then you check which one, the one with the least connections, this one. You send it to this one again, and now this has 4 open connections. It has 4 open connections. Then you try to decide, you get another request, you try to decide who you should send it to. You look at the connections, you see that both of these are the ones that have the least connections. And if you go through like order of like the number of the server 1 would go first. So you send the next connection to this one. It goes to 5. Then you would send the next connection to this one. It goes to 5, and then 6, 6, 7, 7. And you keep going. What it does is it basically sends the next HTTP request to the server with the least connections. That's the whole thing of what it does. Now the other one, which is a resource-based algorithm. Okay, a resource-based algorithm, instead of looking at the amount of connections, it's going to look at the amount of resources that each server is using at the time. So that is going to be in CPU utilization is how we do it in my app, and it's basically what percentage of the CPU time is being used in the current server like by the process in the current server. So let's say out of the whole CPU time, this server has like 50% busy time. What that means, CPU utilization, 50% CPU utilization. What that means is 50% of the time the server is doing work, right? So it's free 50% of the time, it's busy 50% of the time. Now this one might be like 20%, so it's busy 20% of the time, free 80% of the time. This one is, let's say, like 80% CPU utilization. So in the last few seconds, it's been busy 80% of the time. And this one, let's say it's like 99% utilization. So it's busy 99% of the time in the last few seconds, according to like the previous data. So you would use this information for the load balancer to tell which request it should which server it should send their next request to. And it's gonna pick the one with the lowest CPU utilization, the one that's the most free to receive more tasks. So this one has 20, so it's gonna be the one where it sends the next request. And these numbers update every. I mean, I have set up a script that asks for the status of the server, and then based on how much CPU it's utilizing, it updates the load balancer on what the CPU utilization of that server is. So it has a script that every like X amount of seconds, and this is configurable by the user, it goes as every server how busy they are, and then it updates its table with all of the information on how busy each server is, like what's the CPU utilization for each of the servers, and then it uses that table to figure out what the next request should be directed to. Okay, so those are the two algorithms that we built right there. What other things did we do? I mean, let's see. Let's do a git log, and then let's do a git diff from the previous commit. Git diff. Okay. We changed some of these logs. We created the least connections. We created the resource based. We updated some of our logic for the round robin because before it used to send the next request as like being, it didn't matter if it was a healthy or unhealthy server. So now in our algorithm, we're skipping any servers that are unhealthy. We added the connections to support the like least connections thing. We created the new least connection, new resource based algorithms for the scheduler. Oh, I also had a problem with, I mean, it wasn't a problem with concurrency, it was a problem with something else, but I updated. So before I used to have like for the connections part, let's see, let's look it up. Add connections.add. I mean, let's see right here. Oh, okay. So before I used to have like a mutex here, and what a mutex does is it basically locks down your data structure so nobody else can modify it for a second, and then it unlocks it when people can touch it again. And this happens because there are multiple like processes trying to access the servers at the same time, and so if they try to modify the information at the same time, you have what's called a race condition, and that is you might have like you might have them both like adding to the number, to adding +1 to a count at the same time, and when it does the update, they don't like do it in sequence where it first adds 1 and then it adds 1. They do it at the same time. So after the calculation, because they're doing it at the same time, it might just add 1 instead of 2. So you're gonna run into a race condition because you have multiple processes trying to modify the information or read it at the same time. So that's why you use a mutex. But I was told by Gemini that the best way to do this would be to use an atomic int. So that's what I decided to use. And it's pretty similar. The only thing is like the mutex just locks down your whole thing, whereas the atomic int, it just locks down that specific integer, so it doesn't lock out everything else. So it's technically a little bit better, but that was not the problem I was facing. It was some other part in the logic that I had to fix later and figure out. And talking about Gemini, I think I'm gonna have to ask it a few questions, because we're writing tests for our app today, and I'm not exactly sure how I should write said test. Like, I have some ideas, but maybe I might like a plan from Gemini to like explain it a little bit better on like what the best way to do it would be. I still want to write them myself because I think it's good practice, but I kind of need like some sort of guidance because I don't do this often, and like seeing what the standard it is for that, it might be helpful. So let's ask it here. Okay, let's say I want to create test for my Go load balancer project. Can you help me create a, okay, for, let's say, for each of the packages, or like the modules and packages in this project, could you help me come up with a plan to write unit tests for all of their functionality? Don't write any code, just help me plan out how I am going to write the tests for this project. Yeah, I think that more or less makes sense, but we can prompt it again if it doesn't give me relevant information. Okay. I'm surprised it reads them that fast. It says, I will begin by researching the project structure and core logic to understand the interfaces and dependencies that require testing. Okay. Okay, so it says package server. So this is the declaration for the server right here. And right here we just have a definition for the server. We have some functions to like set healthy, add connections, remove connections. What does this do? It returns the amount, it returns the connections. Okay, that makes sense. So the server struct is the foundation of the load balancer. Test should ensure state changes are thread safe and accurate. Initialization, verify that a new server starts with the expected default values. State mutations. I'm probably gonna just create a new window for this. It's hot today and I decided to wear a sweater. Okay. And I'm gonna need some inspiration because I wrote some tests for my HTTP server in Go, but I need to like take some inspiration from that to write the test here. I will begin by researching the project structure. Okay, yeah. State mutations. Atomic counter increments and decrements correctly. Set healthy to verify that the flag is updated correctly. Run multiple Go routines that simultaneously add or remove connections and update health to ensure no race conditions occur. So this is gonna be the one that's gonna be hardest, I think. Like, simulate like a concurrent test. I might ask help for this one, but I think I can figure out these others. So let's first go take some inspiration from my HTTP project. HTTP from TCP. Actually, let's just go test. So we use the testing package from Go. There's got that reference. we use the HTTP the testing package from Go, and then we use the assert and require from here. This is just some like things they need or whatever. This is a different project, but important here is this. So like in your testing, so this is gonna be the same package that you're trying to test. You import your dependencies. Actually, let me just copy this, and it's gonna be the name of the package _underscore test.go. Okay. Actually, let me just go back and I'll just create it here. So server test.go, and then here package test. No, package server. What does it say here? Missing metadata. Oh, okay. Let's see. Packages.load error exit status go mod tidy. Okay. How do I? So we don't need this chunk reader. This was something that was needed for like something else. And these are our tests. So what I'm gonna do here is just like do that. We're just gonna keep this for reference. So here we're gonna do test initialization. And then actually let me go out into the project and go mod tidy. Okay. IO imported and not used. Fair enough. Let me just keep this. I'll just keep two of these tests for reference. Okay, so test initialization. The test body parse, that's test headers parse. Okay, so test initialization should be pretty simple. You just here and then here is going to be expected default values. So R, I'm just going to use this. This is not, nope, this is not what I want to do. So R, actually server, is going to be equal to, how do we create servers in this? Let me go into my load balancer, and then when we do the register, we appended a server. So let's look at register right here. So this is how we create a server. Okay. So now let's go to my server test.go. We'll paste this. And so, oh, actually it should be right here. So server is gonna be equal to that. To server, and then we're gonna first so what happens if I don't initialize it with anything? It just starts with all the default values. And what are the default values for this? So we have the URL. The URL should start as empty. I feel like, why are the stats public? Where do we access the stats? This is within the server package. This is within the server package. This is different. Stats response is different. Oh, this is within the load balancer where we update the CPU usage. Okay, well maybe this shouldn't be public, because then you could update it anywhere in the code. I mean, doesn't matter. Should you have like a method for this to like set it? Should we have like a setter method? Technically, like proper object-oriented programming, you're trying to limit the access of like your object to only the people that need it. But if we put a setter here, people still could like update it anywhere. We're not adding any sort of control to it. I mean, the only, yeah, so like one control we could add there is the number that they can add. So if they add a number that's like not proper, like they add a number above 100 or below something, then it should like an error should come up. Yeah, maybe I should actually, that would probably be better, because if they can just set whatever value here, they could set like minus 24, and that doesn't make sense for our app. It should be a number for 0 to 100, so we're setting what are the expectations for that. So let's actually go update that. So we have the set for our healthy, it's a bool, that makes sense. For our URL, I mean, I could control it so that you can only add like URL like strings, like have some sort of regex that double checks that it's a URL. I think that's just too much of a pain. Like it doesn't make any sense to do that for me. Like you didn't add a correct URL, no, just add the correct URL. Like that for me doesn't matter, but I see where like you could add an incorrect, like a not valid CPU usage. So that is important. And then the weight should also be a positive number. Could you have a negative weight? No, that doesn't make any sense. But do I want to set weight? Because anybody can modify the server weight. Anybody that uses this package. And they can update the healthy, but that's fine. It should only let you set it as true or false. The string should let you set any string. The weight, that's where we get a little bit weird. Like I feel like these connections shouldn't be open. Shouldn't be. Okay, let's see. Do we use connections somewhere? here to add stuff. Oh no, like we use it here inside the package, so that outside of the package itself. Not really. Yeah, I should update how how public all of my data structures are, but we don't use it outside of it. If has one dot connections, but this is a different connection. This is not the same. Is there a way to search references with Telescope? This is a good question. Where are my keybinds? Help tags, key maps, find files, built-in, grep string, like grep, diagnostic, resume old files. Like SR is search resume. Oh, nice. Not references. Live grep and open files. Searching neovim config. No, so I don't really have like to search references. Like I can go to definition. Oh, go to references. Ah, okay, maybe that's good. So if I go, ooh, okay, it does work. LSP references. GR, nice. I like that. I like that keybind. So yeah, if you see here, the only places where we're using connections is inside the package itself. So this should not be open for everybody. CPU usage. I mean, let's do go references. We updated here, and that's the part that I didn't like, because they could set any value there. So we'll make it private. Maybe just do CPU usage. We'll make it private. Has a JSON tag, but it is not exported. Oh, I see the problem. So wait. Go to references. Because where do we decode it? Decode. No, we decode the stats response, so we don't need that. We don't need that anymore. Yeah, we don't need that anymore. So I can actually just update this to CPU usage. And then here on connections, actually let me rename. Then we do connections. And then rename CPU usage to CPU usage. That is fine. Oh, it doesn't want to do it. I'll just do it manually, I guess, because I have to update those manually anyway. So CPU usage, perfect. And now we're gonna add functions to update the CPU usage. So func, and then this is gonna be s server. I'm gonna disable my Super Maven toggle. Okay. Server, and then update connections maybe. And it's gonna receive a float 64. Cons. No, not the connection. Sorry, the CPU usage. And then it's gonna receive usage, which is gonna be a float 64. And right here, so if usage is less than 0 or usage is bigger than 1, so if it's not between 0 and 1, if it's not a percentage, then we return an error. Return errors.new. Did you do an error again? Errors.new, yeah. Errors.new. CPU usage is not a number, it's not a float between 0 and 1. Okay? Otherwise, we just update it. So CPU usage, so s.stats.cpu usage is gonna be equal to usage, and return nil. Right? An error can be nil. Yeah. So this is how we update our CPU usage. That allows us to not allow any numbers outside 0 to 1. Like you can't use a percentage that is outside, like 200%. You can't have 200% CPU utilization, as far as I know. Maybe you can. Maybe I should double check this. Not this. Where is my Google? Do I have Google open here? No. Okay. Can CPU usage be over 100? So it can if you have like multiple threads. Should I'm gonna do executive decision in my app that it's gonna be CPU usage has to be below 100%. Like if you have any sort of like multi-core systems where it tells you like your CPU usage is above 100, you should fix that somehow. Like you should just give me a single core usage. Or should I let it happen? I think it's fine as long as it's not negative. Like you can't have negative CPU usage, but let's say you can have like more, like 150. I feel like it should be an error, but there are these situations, and I don't want to like enclose people to only be able to use 0 to 100, and if their system is giving them other stuff, and then they have to debug a bunch of stuff. So let's say, let's just say less than 0. Yeah. That also technically allows them to put like 56.8 instead of 0.568. If they want to set it in that format, it just has to be consistent all throughout. But no negative numbers for sure. So CPU usage cannot be a negative number. There. And then we update the usage if there's no problem, and we return nil. Okay, so we fixed that. For connections, we didn't use this outside, so we don't need to update anything else. Stats should probably also be private. I mean, where else do we use it? Here we use it in server. This is gonna be updated anyway. What does it say here? Server stats, CPU usage. Oh, we need to be able to get that somehow. So we need to create a getter too. Func. So I'm just gonna copy this. Yeah, let's create a getter. CTC. Get CPU usage. We're gonna say there's no errors. There shouldn't be any errors for this. And we're just gonna return s.stats.cpu usage. What's the too many return values? Oh, right. So here. Oh, maybe you should do like get stats instead. Yeah, just get like a blanket one. Get stats. Because we could have like get connections, I guess, but maybe just get all the stats at once and then you can figure out in your app which ones you want to keep. So get stats is gonna return a stats object. Return copies lock value. Ah, I see. So I do have to have them separately because we already have connections to get connections. So yeah, let's just say get CPU usage, and it's gonna return a float 64, and that's gonna be our s.stats.cpu usage. Perfect. So we have a getter and a setter. Wait. They could technically add a negative weight, and that would break my app. That would break my app because like the way I do weight is like I save it and then I decrease it by 1 until it gets to 0. Do I do it until it gets to 0? Maybe. Weighted run robin. I do well it's bigger than 0, so technically it wouldn't break it, but it's not what's expected from the app. So let's not make this public. And also healthy shouldn't be public. Oh, because you have set healthy. What is the default default bool value? I feel like it's false. Yeah, it's false. That would make it slightly annoying. But there is a problem where they could try like modify it manually, and they shouldn't be let. We shouldn't let them do that. Yeah, so this shouldn't be like an open field. We're gonna have to fix a bunch of errors, but that's fine because this is just better software design. Okay, so our stats aren't gonna be open. Actually, let me rename this to lowercase stats. Okay, just look up stats here, and then update stats. Should be fine here. Healthy you shouldn't let them set that themselves. Healthy URL, I'm gonna let them set it themselves. I don't really care if it's a URL or not. Yeah, I don't need a getter and a setter for this. They can figure out what their URL is, and if they don't put it correctly, it's their fault. I'm not gonna actually like validate it. And the weight. Okay, so we have set healthy. Now we have to create a getter because they can't access it directly. So func s server get healthy. It's going to return a bool. we're just gonna return s dot healthy. Okay. URL, I need to change anything. We need to do something for the weight. So let's do here func s server set weight, and it's gonna get an int, and it's gonna return an error if weight is less than 0. Return errors.new weight can't be negative if w is less than 0. Otherwise, s.weight is equal to w. They can set it to whatever weight they want and return nil. And now we need to do a get weight. And it returns an int, and it returns s.weight. That's our getter. So stats is done. We have CPU usage and connections. That's done. Healthy, we have a getter and a setter. Weight, we have a getter and a setter. So this should be good. Now let's go and search the diagnostic. There we go. So this is a test. I'm not gonna go actually and read that. So we can skip all of these. But here we can't just get the weight automatically. So here instead of weight is gonna be dot get weight. Right? Before we used to get it like that. Now we get it like this. Here instead of healthy, it's gonna be get healthy. Should it be get healthy? It shouldn't be healthy, it should be health. No, because it's internally we're checking if it's healthy or not, so it's a bool of like true or false. But this method should be get health. So I'll rename them after I'm done doing this. And let me just double check that I do this properly. Yeah. Okay, that's done. Search diagnostics. So here, healthy. And this is server stats. This is some internal thing. So we can just do here, get healthy. Search diagnostics again. Actually, search diagnostics. Get healthy. And CPU usage, this is gonna be get CPU usage instead. And this is better because they're not accessing like our internal like stats object directly. Do I have any more errors here? Nope. And then this setter right here. Let me go fix these first. So here it's gonna be r.set set CPU usage. Do I not have a method for that? Oh, I have update. Why do I have update? Okay, no, let me go change that. Why am I using this language? Set. Just getter setter, not getter updater. Set CPU usage. So here's gonna be r.set CPU usage to status CPU usage. And that returns an error, right? Yeah, so E this is gonna have to like, we're just gonna log it out. We can just log it out, I guess. Or okay, who calls check health? Check health. This subroutine. And who calls the health check routine? It's called outside. So if I pull it outside, what am I gonna do? I can't just stop the server. I'm just gonna log out the error. Yeah, I'm just gonna log out the error here. So if error does not equal nil, you do log.print line could not set CPU usage. I'm just gonna say here like error could not set CPU usage in server I'm just gonna actually like get the index. Why not? Server I, and then we're gonna just print the error. Yeah. It returns a string. What does this do? What does this do? It doesn't say. I mean, let's do error. Do we use that anywhere? No. Just print the error. Could not set CPU usage in server I, and then it prints the error. Perfect. Okay. Keep searching our diagnostics. I have an error here. We're setting the healthy to false. Oh no, we're checking if it's equal to false. So here we can just do get healthy instead. Do we have any other errors? No. And this is our server test. Ignore that for now. And now we fix these. Oh, we need to create a constructor. Yeah, we'll create a constructor. Okay. Server.go. We're gonna create a func. It's gonna be new server. And it's gonna get a few things. So what are we're getting the healthy and the URL. We don't need to get the healthy anymore, we just need the URL of the server. How does it assign the weights? How does it assign the weights? I guess you just set them. So I should add that into the constructor. Yeah. Sure, like it'll just register on the server, and if they're not using they're not using it. Yeah. So we're gonna get not the CPU usage, not the connections, those should be updated automatically by the program. Our healthy should just start at false. We need to get the URL. I mean, now that we're just updating it like this, just don't make it open. So URL string. Do you ever need to get the URL? Maybe. You know what? Let's keep it open. Doesn't really matter. So URL string, weight int. We're just gonna call it W. Do anything else? Healthy, it just has the default value. And now we're gonna return like a server. How do you do this again? It's not a percentage, an ampersand? Yeah. You return a reference to a server. with healthy false, URL as URL, weight as weight. The stats can start with the default values, fine by me, and the mutics can start with the default value. Too many return values, right? Because here we have to return a server. Is it technically like a reference? I don't think so. We'll just rep new. New whatever. Oh, okay, it should be a pointer, so you do that. Perfect. And now we can go into diagnostics right here. So lb.register server dot new server and then URL, we just pass the URL that you give it here. And the rest is just, like, you just pass it the URL for this case. And then here, we're gonna update these URLs. 6967 and 6969. Why is this an error? Missing comma. Oh. We do need the second one. But now are you getting angry? Not enough arguments. Oh, the weight should be an optional. Can you do optional arguments in Go? Where am I going? Oh, I don't have Google open, I guess. Optional arguments, Go. It doesn't. Functional options pattern. New server ops option. I don't get it. Opt S. It doesn't have method overloading. Okay. But this doesn't help me. Okay, I think what we're gonna do instead is you only set the URL on ooh. Yeah, you only set the URL on creation. You don't set the weight. And then you can set the weights after. You can just like modify it after. That's like the opt-in, you're just like building your thing. Yeah, that's fine. So here we're not receiving a weight. The weight can just start with the default. What's the default value for an int? Zero. No, it should start at 1. Like you repeat it one time. Okay, let me see the way to run Ramen. If length of servers, okay, that's fine. So it picks the next one. If the current server is healthy and repeat is bigger than 0. It switches us to the next server and then returns that. Okay, but if this starts at -1, or the cursed server starts at -1, okay, I feel like there is an error here though. Because it starts at -1. If the length of the servers is 0, then it doesn't go through anything else. But if it's not, then it would check here. Servers.current server healthy. It would, like, this would be -1 to start. And it would error out here. Like if there's one server we're gonna go pick it, it would check this first. That's a problem. But also, yeah, the weight, if it's I mean, in my opinion, they should all the weights should start as 1. All the weights should start as 1 because you're only repeating each one time. Not as 0. 0 doesn't mean, like, for me, if something has a weight 0, it means don't do anything with it. Or should we have it where, like, weight 0 means just do it once and weight 1 means repeat it once and so on, which means the actual weight. That doesn't make a lot of logical sense. Like, it's easier, like, that's how my app is working right now, but it doesn't make a lot of logic, so I should probably have it the other way. Now how do I fix that? I should have this check right here after this. Maybe? No. Yeah, okay, yeah, maybe this should be after, but I don't want it to pick the next server until it's done all of the repeats. So how do we do this? Because I want it so after you pick the first server, you reduce the repeat by 1. And if okay. If the repeat is 0, we switch to the next one. Only if the repeat is less than or equal to 0, we switch. So we flip the logic basically. Okay, maybe. Okay, let's pop this up. So if repeat is less than or equal to 0, we pick the next server and update the repeat. If our repeat is less than or equal to 0, we pick the next server and update the repeat. Then We should do like a while here. Or like 4, maybe. For r.repeat is less than or equal to 0, pick the next server. And update the repeat. So if the server is -1, which is the only thing place where it errors, where like the index is not valid, so then we can also add here servers like r.curServer .get healthy. So while r.repeat is less than or equal to 0, or the current server is not healthy. This should be this instead. If it's not healthy, just get the next server. And then we always reduce the repeat. Right? Let's think about it. Also, should this be concurrent? Like the load balancer. Could this be updated at the same time? Yes, I think. Oh, but you have a mutex. Yeah. So we have no problem with that. Okay, so this logic stays the same. If the length of the servers is 0, like there's an error. We just return back to the default value, which is -1 and 0, and then we return an error. Otherwise, if the current server, so if our repeat is 0, so in the default value, it will do this. Okay. Or if our current server isn't healthy, pick the next server. We keep doing that until we find a server that's healthy. What if none of the servers are healthy? Then it would go into an infinite loop here. We should provision for that. We could say there are no healthy servers. Should we unregister unhealthy servers? No, because they can become healthy at a later point. We should, like, the user is the one that should, like, unregister them. And I don't have a function for unregistering servers, actually. But, we don't want to go into an infinite loop here. So we're gonna keep a count called tries, which is gonna be equal to the length of the servers. And then we're gonna do tries minus equals 1. If tries is less than or equal to 0, then we return an error. Couldn't find a healthy server. Couldn't find a healthy server, or the weight of all of the servers is 0. But actually, on our set weight, we shouldn't let them do that. So the only time where repeat is 0 is where repeat is 0 is either we've run out of repeats or the default value. Couldn't find a healthy server. and we reduce our try. So we're gonna check if we've checked more servers, like if we checked all the servers and none of them are healthy or have enough repeats, then we couldn't find a healthy server and we just return nothing. Are the repeat minus equal to 1? Okay, let me check this logic. Like, these should be simple, but I feel like there are tiny things you have to pay attention to. Okay, so let me do a little paint like pseudocode for it. So our pseudocode goes as follows. When we go into next, what happens? We check our list of servers. If there are no servers, if this is null, or like there are no servers in there, there's an error, we can't pick any server. Okay, so now we know we have some servers in here. Then, like the last server we picked, would we have the curse server, and then the repeats, right? And so the repeats, for the repeats, like for the previous server, if this number is bigger than 0, if it's like 1, 2, 3, then we know we stick around with the same server and return the current server. So like it goes here, are the repeat is bigger than 0, so it's not less than or equal to 0, so it goes out. Is it an OR condition? I always get messed up with these. Let's think. Yeah, it's an OR. If it's less than or equal to 0, it goes into this. Okay, so if it's not less than or equal to 0, if it's 1, 2, or 3, or whatever number, then it checks the second condition. It checks if the current server is healthy. And if it's not healthy, it picks the next one. Yeah, that is correct. Okay. So, in the case, so we have two cases. Our repeat, like our past server, we still have some repeat left. So we don't pick the next server, right? So if this is bigger than 0, we don't pick the next server. If this is bigger than 0, we don't pick the next server as long as the current server is healthy. So we only pick the next server if we ran out of repeats, and if we ran out of repeats, or if our current server is unhealthy. The only time, okay, it's better to phrase it this way. The only time where we stay with our current server is we haven't run out of repeats and our current server is healthy. Otherwise, if either of those are not true, we pick the next server. Yeah, that seems good. We go into this loop. Then we have a tries that is initiated to the length of the servers, because we're gonna try the next X servers, and if we keep trying, and we've tried every single one of them, we need to return an error. So if our tries is less than or equal to 0, we return an error. Otherwise, we pick the next server, it goes through this condition again, and we decrease tries by 1. Okay. Because you could have an infinite loop where all of the servers are unhealthy. So it always goes in this loop. And it keeps cycling, and it never finishes. Okay. This is why it's good to write tests. Now I'm wondering, because I don't do this often, I normally manually test, how many times I've missed stuff and I have errors all through my app. So this is important, because then when you write the test, you find out these things. By writing the test, you think of where could it have an error, and then you find out of the errors you have, and then also for future times, if you modify anything, it tells you what you come back to this error and you know what to fix it, how to fix it. Okay, so this seems right to me, but we're gonna write tests for it to check. Oh man, this is gonna take a while. Maybe I'm gonna need to have another session next week. Okay, this seems good. I don't know what I was doing before this. Oh, so for our set weight, we need to, if it's less than 0, no, if it's less than or equal to 0. Weight, we're just gonna say weight has to be bigger than or equal to 1. It can't be 0 because if you have weight 0, we just skip that server. At that point, just unregister the server if you wanted to skip it every time. So don't allow them to put it 0 or less. Okay, we've updated our assumptions. Do we need a mutex for all of these? Yes. Because the, like, 2 threads might try to update the same server at the same time. So we do need a mutex here. For get weight, connections don't need it because it's already an atomic int. For setting the CPU usage, and for getting the CPU usage. Because you could try to like update them at the same time, and that's bad. So we have our mutex to fix that. Oh, we wanted to start healthy as true, not false. And our URL as URL. Weight shouldn't start at 0, so if they don't add any weight, we're just gonna make weight 1. Weight always should start at 1. Because that means do it 1 time. Weight 0 shouldn't be possible. God, why is my nose so itchy all the time? Okay. Yep. Okay, this seems right for now. I might find some errors later, but for now it seems fine. Do we go back to the testing? I mean, do we have any other errors? Yes. Up here. Oh, okay. I think this is where we were before. Because we were trying to set the weight, and then I figured out the whole thing, what if the weight is like 0. Okay, so we register all of our servers, so we can delete this. Weird. This music is sometimes very weird. Okay, so we go back to server test. This should help us come up with other problems. So this server, this doesn't exist. What happens if you create it like this? Oh, that's why they shouldn't be open. This is not gonna let me do this, right? Yep. So now how many diagnostics do we have? Yep. Okay. That server? How do we specify the type now? Ah. Like it's an interface? What is the difference? Is this the difference between an interface and a type? an interface, and a type in Go. Yeah. So we should have like a server interface. Okay. Man. Okay, well this is good knowledge though. How do you do interface server? You do like this? Go interface. Do you have like an example? Type interface. Okay. So type server interface. And then this is what it's actually going to be, the server. I mean, okay, should I have both a type and an interface for the same type in Golang? Okay, maybe this is a question for Gemini. Okay, so if I have a type in which I want to have a, in which I don't want, programs outside my package to, use the default constructor. If I have a type in which I don't want programs outside my package to use the default constructor, but I do want to let those programs be able to refer to the type, because what is the thing that's using it right now? What is the thing that's giving me errors? Oh, what did I do? Okay, yeah. Okay, before I did this, actually. For our make load balancer, yeah, we need to make an array of servers that we're going to use for my load balancer. But I do want to let those programs to be able to refer to the type structure, to extend the functionality. In this case, should I create both a type and an interface for the same type? I don't know if that makes sense. Analyzing extend functionality. Huh. Might just, no, I don't think I'm too small. Okay. The recommended pattern: interface plus an exported struct. Export an interface that defines the behavior. This allows other programs to refer to the type and implement their own version. Keep the concrete struct and export it. Provide an exported constructor. Yeah, so this is what I did. When should you export both? Yes. Okay. So I should. What I was trying to do, it is correct. Technically, they shouldn't have access to these, so they should only have access to the URL. How do interfaces work? Yeah, I think. Oh, it defines the behavior. So interfaces don't actually have any methods. That is interesting. Where did I have? Yeah, I had this open. So you have methods. So I need to put in all the methods I have in my interface. Okay. So type server interface, we're not gonna have the URL itself. It's gonna have a set healthy, cool, something like that. What does Gemini say? I'm just gonna copy the signatures. So this has set healthy bool, and it returns nothing. It has a get healthy, and it returns a bool. It has a set wait. Is there an easier way to do this? Set wait w int returns an error. Get wait returns an int. We have get wait, add connection, remove connection, connection, CPU usage. Okay, you know what? Just gonna copy all of these and then paste them in my interface and then just modify it. So DTA. Then boop, 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 remove that. DT. Okay, DTR. And it doesn't return anything, so we do that. D2W? No. What would it be? DF that. And then doop 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 doop. DF that. Doop. Remove all of this functionality because it's only an interface. DF that. Remove all this functionality. And now we put them all close to each other. Yeah, so now we have this server interface. Now let's look up server.server. Do those work? Yeah, they do work. Okay. So we have our server interface that allows them to access the methods of my server. Do I need to have a set URL and get URL? You know what? Might as well do it. So func s server get URL, and it's gonna return a string, and I'm just gonna return s.url, and then set URL. Set URL. You're gonna get a URL string, and then here s.url is gonna be equal to URL. And here we have set URL, URL string, and get URL returns a string. Perfect. So we have our server interface. Let's go to the diagnostics and try to help fix these now. Get weight. Pointer to interface, not interface. What? What? What does this mean? So we don't need to have this be a pointer anymore? Ah. Interesting. Same with this. It doesn't need to be a pointer anymore. Huh. Search site. How do I do? Do you do next diagnostic? No. Just do search diagnostics, sure. Get healthy. So basically, I'm just gonna look up. An easier way to do this is just to do a grep search of server.server. Because if we remove that, and then how do you do resume search? Is it RS? I don't know what I just did. Oh, SR. Stay search resume. Yeah. So we just did this one. Search resume. I feel like that's right. Then down here, do that. And then do that. These are correct. Okay. Search resume. Now we only have one here. Yeah. What are our diagnostics now? What does it say? Cannot use server, then use server, value of type server, that server, as server, that server. Oh my god. Value and assignment to LB or register. Does not implement server, that server. Missing method get URL. Now get URL is here. Oh, right. So here is not get URL, set URL, like these should be uppercase. Now if you search diagnostics, those should not be there. r.url undefined, yeah, because this should be get URL. Get URL. Get URL. This is request from reader. Oh, this is from the test. Are all the remaining errors from the test? Yes, it appears so. This is not what I meant to do. It appears so. So we fixed the errors. Sick. Okay, so here server is gonna be new server. And then I don't know what to call it. The localhost 12345. Sure. And now what did Gemini say we had to do for this? Verify that it starts with the expected default values. Sure. So it would be require no error, T error, or not nil. Assert dot equal. So what does assert do? Oh, a bunch of things. Okay. Equal? What is the difference between require equal and assert dot equal? Difference between require dot equal and assert dot equal in Go. How they handle test failures. Both functions compared to objects are equality by differing when their text execution continues after a failure. Assert dot equal non-fatal. Require dot equal fatal. Ah, okay. Which one's fatal? Require. Require is fatal. Okay. So server, new server, 1, 2, 3, 4, 5. So what fields do we have here? We have stats, stats.connection, stats.cpu usage. State mutation, stat connection, set healthy, verify the flag is updated correctly, and then concurrency. Huh. Okay, so this should be a pretty simple test, and that is, we're gonna say assert.equal. How does this work? T. Our server dot, let's do it healthy, and it should start as true when you create it. Assert dot equal server dot URL, and it should be the same as this. I mean, I feel like that's, I don't know if I need to write a test for that, but why not? So server.url, what else are we testing? Wait. So wait should be 1 to start. This one is important, I think. Assert.equal server dot. So we done wait, URL, and healthy. The mutex, I don't really care what it starts at. The stats, I don't really care what it starts at. The connections and CPU usage, it doesn't matter what they start at. but this should start at 0, I guess. Nah, it's fine. Oh, actually, I should check that like server.connections is equal to 0 to start. And CPU usage I can ignore, but the connections should start at 0. Okay. So this is initialization. State mutations, health status. There used to be a big package, so that's where you had like headers, parts, body parts. They have multiple parts. Server is just kind of like a type with like multiple setters and getters. So here I would just be testing the setters and getters. So the initialization, I think this is fine. Here we do func. So we're gonna test. Let's test all the setters. Yeah, let's test all the setters here. And to test all the setters, what we're gonna do is, what do we want to do? So what are our setters and getters? So we create a new server as such, and then okay. So what are our setters and getters? Test server dot. So let's do set CPU usage, and this one it doesn't let you do less than 0. So we should okay. So test test set CPU usage. Correct value. So if we set CPU usage to 1.3, no, like 0.69, let's say, then we need to first assert that there's no error. So here we get the error. And then first we need to require that there's no error. And then second, because this only returns an error, okay. Second, we need to assert equal t. We're gonna assert that our server.stats.cpu usage is gonna be equal to 0.69. And now we're gonna do the same, but for an incorrect value. Set CPU usage, incorrect value. Oh, this is correct. Valid. We're just gonna call it valid instead of instead of incorrect or correct. And with that same server, yeah, with that same server, we can do this with the same server. So with that same server, we're gonna set the CPU usage to minus 0.420. Why not? And then we're gonna require an error. Is this a thing? Error asserts that a function returned an error, i.e. not nil. Okay. So we're gonna require an error. Let me see one thing. Yeah, so you just require an error. It's like how we do it here. Okay, so we're gonna require an error because set CPU usage negative CPU usage. That's an error. We don't need to have assert.equal. I mean, we could say that it's still equal to 0.69. Maybe? that it didn't update it after, like it returns an error and it doesn't update it. Yeah, sure. Okay, so we did for set CPU usage. Let's do the next. What would be the next? Server.set healthy. So it doesn't really return an error, so it should be pretty simple. If you set it to false, it's going to be false. Test set healthy, and then we're gonna assert equal assert true. We'll do assert true, why not? Assert true test, and then we're gonna pass our server.healthy. Oh, actually, I wanted to do something, and it's instead of set healthy, it's set health. Renaming this method to would make no longer assignable to interface server. Okay, so we need to update this first, and then we update that. This load balancer has errors. Actually, this is, let me just... this is so annoying. Okay, we'll just do that. Yep, sure. Set health false and assert dot false actually. Server dot healthy. Okay, pretty simple that one. Now we're gonna test. What are we gonna test? Server dot set URL. This should also be pretty simple. Server.set URL https instagram.com, why not? And then we're gonna say assert equal, do that, and then this is gonna be equal to our server.url. And then lastly, we're gonna set the weight to test set weight valid value. So server dot set weight 69. We're gonna assert equal. Okay, well, set weight returns an error, right? Yeah, so error equal that. We're gonna require no error. And then we're gonna assert dot equal server dot weight 269. And now we're gonna do the same, but for set weight negative value, because I think that's when it returns 0 or negative. Yeah, set weight value 0. I'm gonna say it's at 0, and then we're gonna require an error and that it's the same value, didn't update it. And then here we're gonna do one for negative. Test set weight value negative minus 420. Why not? Require error and that it didn't update it. Perfect. So we tested all of our setters, and now we're gonna test all of our getters. Now we're gonna test all of our getters. Just 1 second. Okay, so we're gonna test all of our getters. Let me just delete all this. So in here, what getters do we have? We're gonna create a new server, and it's gonna be just localhost 420.69. Why not? Server.get. Get URL, get healthy, get CPU usage. We have 4 of these. They're all pretty straightforward, I believe. I mean, let me go here. Do any of them have any nuances? Oh, this URL and set URL, it should have a mutex. So as I'm just gonna copy this. Okay. So it should all have the mutexes except the ones with the atomic ends, because those don't need it. Perfect. Go back. And they're all, were they all pretty straightforward? I don't remember. Server. Get just returns it, this just returns it, this just returns it, and this just returns it. So I think it's fine. I don't think I need to test the getters. Like, they're pretty simple. I just need to create it because because I didn't make it a public type. So we're not gonna test the getters. Did Gemini tell me to test the getters? Add connection and remove connection. Ooh. Okay, so maybe test the atomic int. We could do that. So test connections, sure. Or should that be in this? I feel like that should be in the setters and getters. In the setters right here. So we're gonna do test add connections. So we're gonna, do we assert that the connections are 0 initialization? Yes. So test add connections. We're gonna server.add connections. This doesn't return any errors. And we're gonna assert dot equal t server.stats.connections. Oh, nope, I need to access it through this. And that should be equal to 1. Then if we do this process again, I'll just do it, it should be equal to 2. And now we do the opposite. Test remove connections, is that it? Yeah. And it's gonna be something similar to this. Remove connection. Remove connection. And we're gonna assert that it's 1 and then that it's 0. Okay, so we've tested our add connection, remove connection, and now we need to do concurrency. I'm actually gonna ask Gemini to help me out with this because I can't think of how exactly. Check my server tests go file. I have created tests for initialization and for all. Actually, let me just create a boilerplate for it. right here, and instead of test initialization, it's gonna be test concurrency. Okay, so I've created test for initialization, and now for all my setters, could you create the like tests for concurrency inside test concurrency function? Okay, let's see. Oh, just like that? Okay, let's see what I created. So, test concurrency, it creates a new server. Okay. It creates a new server. It creates a wait group with 1,000 iterations. Add to defer wg.done iteration server.add server.remove connection. I don't know how this works. And why aren't there so many like asserts? Okay, let's let it do it once. Why not? No. No, don't run the tests. For loop can be modernized using range orient. Could you explain what the code you added does line by line? So setup. It creates a new server, then a wait group is used to track active Go routines. It ensures the test doesn't finish until all background tests are done. Sure. Iterations, 1,000. Determines how many times the operation will run to increase the chance of catching a race condition. Okay. WDG.add2 tells the wait group we are starting 2 new Go routines. Go func add connection adds a connection 1,000 times. Okay, and then remove connection, it removes a connection 1,000 times. Defer wg.done. Okay, I'm finished once it does it. Okay. WG.add2 adds 2 more Go routines to the counter. It sets health, rapidly toggles the health status between true and false. Okay. The same thread updates the weight. What does it update it to? To a weight between 1 and 10? Sure. Set CPU usage below and set URL. A separate thread simultaneously updates the CPU usage in the URL string. This tests if the sync.mutex in your struct correctly prevents these threads from interfering with each other. Adds 1 final Go routine. Get healthy while the other 4 threads are busy writing data. This thread is busy reading it. This ensures that reading a value while it's being updated doesn't cause a crash or return to garbage data. wg.wait and assert. This is the smoke test. So we added exactly and remove exactly 1,000 connections. Okay. For the atomic int, that makes sense. For the setting, I mean, you're setting URL to this every time. That doesn't really make a lot of sense to me. Because this is just updated once and then never changing it again. I'm just gonna ask it, how come we only have one assert statement at the bottom? How are we testing the other changes to URL, usage, weight, and health? Get healthy. It shouldn't be get health. It should be get health. There's a great observation. We have one assert for connections and not for the others. Comes deterministic and non-deterministic results in a concurrent environment. For fields like URL weight and CPU usage, we have multiple Go routines rating different values to them at the same time. Because we don't know the exact order in which CPU will execute those 1,000 loops, we can't predict what the final value would be. One thread might set the URL to update a URL at the last microsecond, or another one might have just finished a read. The test for these fields isn't actually a final value, it's the absence of a crash or a data erase. If you run the test with a erase detector, Go will watch those memory locations. If two threads try to write URL at the same time, without your sync mutex working correctly, the test will fail immediately with a data erase error, even without an assert. Oh, I didn't know this was a thing. Go test minus race. Data erase detector. Monitors memory access at runtime to identify data erases. The data erases when multiple Go routines would access the same concurrently, and at least one of those is a write. Ooh! I like that. Okay. Interesting. Okay, so we're gonna update here get health to get healthy. Get healthy to get health. Does that give me any errors? Yes, here, get health. And here, get health. You know what? Just do like get healthy. Update it here. Search resume. Search resume. Search resume. Search resume. Healthy. Nothing. Okay, so we go to test. Okay, so let's say here it gave me the command. It was gonna run what command do I use to run the tests, run all of the tests we just created? Recommendation for concurrency, go test minus v erase package server. Oh, let's see. Okay, fail? Server test go not equal expected in 32, actual int 0. Okay, so the 0 and 0, 1 and 1, 2 and 2, 1 and 1. So they technically didn't fail, I just didn't do this properly. Okay. Server test go 65. And then we go to 65. It returns an int32. What's the difference between an int and an int32? Difference between an int and an int32 in Go. Int is assigned integer type that it's at least 32 bits in size. It is a distinct type, however, and not an alias for, say, int32. Okay, but it is okay. So here the problem is on my test that it should be an int32. Should I use int32 for mine? It probably doesn't matter. Okay. Let's try the test again. Error.trace expected int32. Okay. Oh, what, sir, it was a 0, right? Oh, right here. They all passed with okay, I think. Test initialization, pass, perfect. I mean, that was the simpler package for tests. Now we need to do the other packages. So if we go up to the top here, and okay, I want to see something though. What if I remove the mutex from like one of them? What if I remove the mutex from like here? Let's remove the remove the mutex out of all of them. And now we do the go test. It failed. Okay. Raise detected. So the mutex is doing something. Data raise. Yeah, so the mutex is doing work there. And we do not what I meant to do. We go to server. And okay. Yeah. Cached. Okay, fair enough. Okay. It's nice that it like caches. I don't know what it caches here. Does it cache like your program code that you didn't change it from previous runs, or does it how does it cache it? We'll see. Okay, so we've tested. We tested the package server management. Now we need to test the other ones. Those are gonna be a little bit harder. But I have 4 packages total, so we have done 25% of the work so far. Maybe let's try doing like a second one. We'll see how long this one takes. And then the other 2, we'll see. Okay, well, we'll see. Well, let's just start with the algorithm one. So, and then that package algorithm. And here we're gonna create algorithm test.go. And then let's go to server test.go, copy all of this, go back, do that, and then this is package algorithm instead. Algorithm that shouldn't need any concurrency, so that should be fine. And here it says test common edge cases, empty lists, ensure all our algorithms return an error when the server list is empty, unhealthy servers, verify how each algorithm skips or handles servers marked as healthy false, and then we do specifics. Okay, so I should probably write a test for each of the algorithms. So test round robin. We do test round robin. We do test weighted round robin. We do test least connections, and then we do test resource based. And the thing here is we don't actually need to like create the values. Like, okay, we don't actually need to connect to a server that has like, for like release connections and resource based, we don't need to actually connect it to a server that has like X amount of connections or like 20% CPU utilization. We need to mock real world conditions. We just need to like add those to the array and then test that it's doing the algorithm itself properly. We don't care if like in reality like there's some problems with like HTTP connections or whatever. We're just testing the algorithm. Like, we're just narrowing our focus to something very small here. Okay. So actually, I'll just do that, and then I'll paste it here at the bottom just for reference. Actually, this doesn't really help. You know what? We don't need a reference. Test round robin. So test. Okay, let's go into the round robin, see what we're gonna have to test. So pick the next server, pick the next server. It doesn't skip them if they're unhealthy. Should it skip it if it's unhealthy? Maybe it should. Because, okay, like our weighted round robin, it already skips if they're unhealthy. It already skips if they're unhealthy. What does our least connections do? It skips if they're unhealthy as well. Okay, and what does our... We have our least connection doing the right thing, and then resource-based should also skip them if they're unhealthy, so... So here we should actually also do it in our round robin, our regular round robin. Our regular round robin, that's nice to say, I guess. So here we pick the next server, and actually so while r.cur server is equal to -1, or r, like the whatever server we're picking, which would be servers.r.cur server get health. Well, it's not healthy. Let's make it more clear. Equals false. We pick the next server. So while we're at the default state, which is -1, if we're at the default state, go in. If we're not at the default state, but the current server is not healthy, go to the next one. Yeah. Perfect. So we do that. We can actually go into load balancer, technically not this one. And here when we check health, it's false, and we pick the next one. We could technically skip this. I'm gonna keep it just in case. But now all of our algorithms should skip any unhealthy servers. It should never give you an unhealthy server. So let's go to test. Right here. Okay, so we create a load balancer, we register servers to it, and then we do other stuff. Okay, so let's do the initialization. LB is gonna be equal to load balancer, or no, algorithm, no, we need to do this. What is round robin? Round robin is, oh, okay. Okay. Wait, let me see one thing. Scheduler. It's an interface. Can we use this interface for our type? How to explicitly say that a struct is extending an interface in Go. In Go, interfaces are implemented explicitly. There's no implements keyword to explicitly link it to an interface. Oh, okay. Method 2 is the correct one. So there's no way to actually do it. It's just implicitly done. Okay. Well. So a scheduler is basically a type that has this function next that receives the server. So we don't need to create a load balancer actually. We just need to create servers. So server list is gonna be equal to what is it, make? Give me 1 second. Where we go to load balancer main.go right here. Server, the new server. Okay. And how do we make the array of servers? New load, we create a new, make LB. Oh, like this. This is what I wanted. So we make that server. What does make do? It creates, it's like a malloc. It creates a slice of servers. Okay, perfect. Of length 0. And there's this append function, right? Slice equals append slice. Okay. Ibiza. Okay, so here we're gonna say server list equals append server list, and we're gonna append server.new server. We're gonna do something like, what is this? We're just gonna, honestly, it doesn't matter, localhost for 2869. And let's append 4 servers for our testing. And let's just make this 1, 2, 3, 4. Okay, so append all our servers. We're testing the round robin, so it should give us 0, 1, 2, 3, 4. And then round robin is gonna be equal to new round robin, right? rr.next is the method, yeah. So here in our test, just the test is gonna be regular. Let's just say all servers are healthy. Oh, actually, let's do a test first. Here. We do a test right here that is test no servers in server list. So we're gonna get an int and an error, right? So we should get index error is gonna be equal to rr.next, and it receives the server list. That's gonna be empty. And then we're gonna require error, and we're gonna assert equal I should be equal to -1. Okay, now we append all the servers. We test all servers are healthy. We append all the servers. This should probably be up top here. All servers are healthy. And so what it should do, do we instantiate a new round robin? Sure. Let's just create a new round robin. So the curse, like the curse server is -1 still. Okay, let's also do this. Assert.equal rr.curse server should also be -1. What other things do we have? If not nil, the mutex, yeah, that doesn't matter. Okay. All servers are healthy. We append the 4 servers, and then we go through them one by one, and it should return 0, 1, 2, 3, 0, 1, 2, 3. So here we do rr.next. Now I'm just thinking, what if the server list either increases or shrinks? Is this handled properly? It could increase or shrink in between calls. So if there's no servers, it returns an error. So that is handled. Okay, but this is a problem right here that I'm seeing right now. When it tries to get health, if it shrunk from the last time, you're gonna try to access an index that doesn't exist. Right? So we know there's at least one server. We also need to check here. R.cur server should be less. When do we pick the next server? So when it's an OR, the first true condition it reaches, it just goes in. So if the current server is -1, pick the next one. Or if r.cur server is bigger than or equal to so what happens in that case? Like, okay, we had 3 elements before. Now we have 2 and we were at index 3. So it should start back from the beginning, right? Maybe let's make that a check here. So if r.cur server is bigger than or equal to len of servers, what do we do? We make r.cur server -1. Go back to the beginning, basically. What if it grew in between? So length of servers wouldn't be 0. We would still be at the same place, and we just have more things to go through. So there's no problem there. The only problem is if it shrinks, and we fix that here. And actually, I should actually just go into my weighted round robin to do the same thing. So what happens if it shrinks here? Our order repeat wouldn't be 0. If it's big, if it doesn't fit, r.cur server would never be. If it's negative or 0. Sorry, if it's. This is get the next server, right? Oh, and then we need to, yeah, that's what we do with our repeat, right? So we don't need to check the cur server here because r.repeat does that for us. So if we finish doing it, or if it's the default value, then move on to the next one. And with this, we also guarantee that we don't go above. Yeah, that when it shrinks, we don't go above. Okay, we will find out in our tests if our assumptions are correct or not. So this is just the regular one. So rr.next server list. It should return an int and an error. So it should first of all return 0. So we're gonna do require no error. T require no error for T and error. We're also gonna assert equal T and I should be equal to 0. And then we're gonna repeat this like a few times. And maybe we don't need 4 servers to test this. It should reduce it. Okay, so let's just do 3. Do that. So 0, 1, 2, and it should go back to 0. So 0, 1, 2, 0. I'm not gonna check it any further. I think this should be fine, because we're checking that it loops back. We've checked when there's no servers in there. We need to check when it grows. We need to check when they're healthy or not. Because if they're not healthy, it should skip it. So let's say now that we go server lists 1. Server list 1 dot set health to false. So now it should skip it. And we should reinitialize the round robin. We're keeping the same server list, but okay, so test one of the servers unhealthy. So we create a new round robin, we set the health of 1 to false, and then we do this same process. But it should go from 0 to 2 and back to 0. Because it should skip 1. Okay, test one of the servers unhealthy. We created that one. And then we do test server list shrunk. So we reinitialize our round robin. And then let's set the health back to true. Okay, so how to remove an element from a slice in Go? Slices.delete. Oh, we just do this. I guess. Okay. Sure. So we set the health of 1 to true again. We do this whole process, but we only get to 1. So r.next server list, no error, it should be 0, it should be 1. Now we shrink it. Now we do server list is gonna be equal to append server list so if we want to delete item I, we do this. Okay. up to 1, and then server list from 1 to the end, from 2 to the end. So yeah, cannot use server list, server value depend server does not implement server as server. Missing method add connection. I'm confused why this is the only error. Missing add connection. Huh. What do you mean? They're both there. There was another way to delete it. They were showing it here or something. Slices.delete. Maybe just do slices.delete server list, and we want to delete this. Deletes 1 to 4. We just want to delete 1 to 2 because that will delete 1. Oh, we want to delete 1. Actually 1 to 3. Server list equal that. We delete everything from 1 onwards. We delete everything from 1 onwards, and now, so it's gonna be including 1, right? Because this deletes everything from 1 to 4. Including 1, so it includes 1, 2, 3. So we delete those, and now it's gonna be a 1, so it should go back to minus. It should go back to 0. So when we do r.next, when we do this, we should assert no error. And we should assert dot equal ti 0. It should go back to 0 instead of going directly to 2. Okay. I'm not gonna test concurrency for this because I don't think it's that important. It already has the mutexes. We've tested with the other ones that it works, so there should be no race condition there. And it's like very, very simple. It's just like the index here, so it's not updated twice at the same time. I mean, we could create a test concurrency thing. Yeah, I'll create a test concurrency thing at the end. But we've done that it does it in order, that it skips any unhealthy ones, and that it manages when it's shrunk. What other things did it say here? it doesn't really catch the edge cases, but no servers and server list. Okay. So we've done the test for this. Now we do the test for wait around robin. We can probably copy most of this in there. We test when there's no servers in the server list that it returns an error. We have 3 servers in this case. All servers are healthy and wait 1. So this should be the same test. This should work the same as a regular round robin. Now we do a similar test but with different weights. So here we're gonna say that our server list 0, set weight to 3, and our server list 1, set weight to 2. So here we get the next server, we require no error, we assert that it's equal to 0, and we repeat this 3 times. Actually, for in range 3. For range go length. This is for iterating over that. But how do we do a for loop from 0 to 5, for example? For range count. Okay. For range 3, it should return 0. Then for range 2, it should return 1. 2. This should return 1. And then the last one, it should return 2, and then it should return 0 again. And we'll just do that. Then we do test. So this is not going to be test all servers are healthy and wait 1. All servers are unhealthy and variable weights. Then we do test one of the servers unhealthy. It should just skip it. We can do it like this. Maybe I'll just move this up. We can test it with the repeat. So we'll do something similar to this. Well, I don't know how much test coverage do we want? How strict do we want to be? Because I feel like if it already skips it, when it's done before, then yes. Okay, we'll do both. Doesn't matter. That's what we're here for. Okay, one of the servers unhealthy. Well, we're gonna do. This is just gonna be this regular one. So I'm just gonna move that up. One of the servers unhealthy. Yeah, sure. Let's just do the same test for... Actually, this shouldn't be new round robin. It should be new weighted round robin. So one of the servers unhealthy, we do it with the same ones here, and it should do 0 to 0. All servers are healthy and variable weights. Server list shrunk. Before we do that, we do that it changes in between repeats. The server health changes in between repeats. Server to be repeated becomes unhealthy. So now we can do this, and we can repeat the same process for the other one. I'm just gonna copy this right here. No, it doesn't make any sense because we need to test first that yeah, no, we need to test first that the weights work. And then we test the other thing. So we put this down here. Server to be repeated becomes unhealthy. We do the same thing as above. A little bit. No, we don't actually. We're just gonna test the beginning. So it should repeat it 3 times. So the first one, it equals to 0. We'll do another one of them. The second one, it becomes it's equal to 0. On the third one, we're gonna say our server list 0.set health to false. I feel like healthy was better now that I think about it. Because get health true, it doesn't return healthy, it returns true. Whatever. We changed the health to false, and now we run it again, and it should go to 1 instead of 0. Server list shrunk. We can do a similar test to the one above, but instead we shrink it. So let's set the health of this one to true. Servers are healthy, one of the servers unhealthy. let's say server1.health equals true. So now they should all be unhealthy because we only made one. We only made one unhealthy here. So we reversed it after. And then server to be repeated becomes unhealthy. We set the health to false. Now we reverse it here. So it should all be healthy again. But we're shrinking it. We're shrinking it, so let's go. Okay, so server list 0 dot set weight to 1, and server list 1 set weight to 2. We don't have variable weights here. Okay, server list 0 dot set weight 3, and server list 1 dot set weight 2. With the same one, it should repeat 3 times, but now we're gonna switch it back to 1, and this one to 2. We'll just set it as 5. So it should go 0, then 1, and when it goes to repeat, we shrink it. Zero, then 1, and then when it goes to repeat, we shrink and it should go back to 0. Zero, 1, 1, we shrink it, go back to 0. Okay, let's double check our tests. Okay. So we create a new weighted round robin. We create the server list. If there are no servers in the server list, we just require an error, and this should be -1. And the current server should be -1. If the oldest servers are healthy and the weight 1, it works the same as the round robin one. So we create a new weighted round robin. We create append 3 servers. Pick the next one 0. Pick the next one 1. Pick the next one 2. Pick the next one 0. We reinitialize it. We set the health of one of them to false. So the health of 1 is equal to false. So now it should skip 1. Did we do this for the one up here? Yeah. Then all servers are healthy and variable weights. So now I have set weight of 0 is 3, weight of 1 is 2. So it should go 3 times the first one, and then 2 times the second one, and then 1 time the last one. So 3 times you should pick the next one, no error equals 0. 2 times you should do this one, and then 1 time you should do this one. We reinitialize it, server to be repeated becomes unhealthy. We have the same amount of like weights, those haven't changed. So then it goes 0, 0, it goes to repeat it 1 last time. We set the health to false, so it should go directly to the next one instead of repeating. And then if the server list is shrunk, we have the weight of the first one is 1, this one's 5. We reset the health. Do we do any other changes here? I mean, let's actually just do set health, and then we reset it. Set weight, we keep them the same because we want them the same. The set health false, we reset it, and then we change the weights here. So it does the first one, it does 2 of 1. We delete the rest of the slices, so now it should go back to 0. Okay. Should we test it so far? Or should we write the other tests? Let's test it so far. Why not? Go test -v -raise package algorithm. Okay. 31, 34, 37, 47, and 60. Expected 0 and got 2. Okay, let me just take a screenshot of this. Let's put it side by side. Actually, I'll put it on my second screen. Algorithm test. So we have an error in 31 right here. It says it expected 0, but it gave it 1. Why did it expect 0? In 31. I'm confused. What is a expected 0? Oh, is it doing it backwards? Expected actual. Oh, okay. I'm using this wrong. So it should be 0i, not I0. Oh my god. Maybe record a macro? Okay. So we do www. We change this to do that. Then we go back, paste it, do that, paste it, delete. And then I queue again. And now how do I run said macro? QA. Running the macro, press @ followed by a. Okay. So I do assert.equal. So I do done a, flips them, it flips them, flips them, flips them, flips them, flips them. Ooh, that one didn't work. Maybe I can do it differently. Let's see, how do we make it work for like longer? Oh, I know how. Record A. So we started here at the beginning. So it should all be the same. We get to here. We do YT comma. And then we do www. W. Go back. P. DT that. And then is it F comma? Do that, paste it, and F comma. Ooh, no, don't do it like this. Start at the beginning. Okay. So we do F comma, do that, dt comma, then F that, go back one, paste, go back, the word, nope, the word, and then F comma, go back, do that, and then delete, and that should be good enough. Oh, did I not record it? Crap. Okay. Me and my macros. Okay. So, QA. We record a macro. We find the comma. We go forward one. We go forward one again. We go dt comma. Delete that. We find the parenthesis. We paste. No, we don't paste because how do we find? Oh, that's what I had the space before. Okay. QA. Find comma. Go forward one. dt comma. Find that. Go back one. Paste. Now we go back a word. We go back a word. We do the word. We find the previous comma. We go back. We paste and we delete the space. Okay. Let's test if it. Oh. Let's test if it works. No. Oh, that's annoying. Why doesn't it work? Okay, I can do this. I can do this. Record a macro. Find the comma. Go forward. Delete up until the comma. Find the bracket. Go back one. Paste that. Go back a word. Go back a word. DW. F comma. Go back. Paste that. Delete. And do that. No, why doesn't it work? Okay, I mean, let me run the same process and see why it doesn't work. Find the comma. Go forward one. Delete until the comma. Go find this. Go back. Paste it. Oh, because it's only one letter, so then it goes back to, it deletes. I see. Because when we were here, it goes back to here. But when we were here, I mean. Oh, I could fix that with like find space instead. Okay, I mean, let me do it with this one then. Record A. We find a comma. Go forward. Delete them until the comma. Go to the end. Paste this here. we find the space, and we find another space. We go forward one, delete the word. Now we find the comma behind, go back, paste it, delete, Q. Yes. Okay, maybe this will work. Assert dot equal. It flips them. Flips them. Flips them. Flips them. When I save it, does it? Yeah. Okay. Flips. 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 It's actual and then expected. Right? Expected and then actual. It expects -1, and then the actual one is I. Same with this one. Expects -1, and then the actual one is expects 0, expects 1, expects 2, expects 0, 1, 0, 2. Yeah. Okay, save that. We're gonna find assert dot equal again in server test.go, and then we're gonna run the macro expected true, actual that. Expected that, actual that, expected that, actual that, expected that, actual that, expected that, actual that. Oh wait, expected Instagram, that's fine. Expected 69. Expected 1, expected 2, expected 1, expected 0. Expected in 32. We save. And now if we do all of our assert dot equals, they should be fine. True, localhost 1, 0, yep. Yeah, so all of them should be fine now. Now we go back to what we were doing instead of before I got distracted by this. And so, okay, on my screenshot it said that it expected 0 and got 1, but it's the other way around. It like expected 1 and got 0, so it's not actually like changing. That's in 31 and in 34. In 31, in 34, and 47. So this number is not changing. The I is not changing. Why is that? I mean, the server list should be fine. Let me just format dot print line. Format dot print line server list. And then let's do our test again. That doesn't help, but we do have 3 things in there. So there is an error in our code. Expected 1, actual 0. And this is only for, is it only for the weighted round robin? No, that is for the normal round robin. So something is up here. Sorry, let me just take a screenshot of this to take a look at now. Vim package algorithm test. So 33 right here. So something is going on with our round robin. Let's check. Where it's staying at 0. I mean, okay, let's print here. So it should return an error here. So that's not where it's having the error. So format.println per server bigger than length of servers. And then here we do format.println r.curServer if r.curServer is bigger than or equal to 0. Format.println we print y word. Okay, let's run the test again. -1. Why does it only go there once? Oh, -1, -1, -1. This is on my round robin right here. It's coming in here and it's -1. It's -1, then it should be increasing it and returning 0. Why isn't the state getting updated? Why is it staying at 0? Does it think it only has... Oh, LAN of servers. If it thinks it only has one server, then that's a problem. No, it thinks it has 3. Does it just not keep increasing it? Is my loop wrong? Why is it going back to -1 every time? Or the current server equals -1. Like, it's not going in here. It shouldn't be going in here. It's always 0. Why? Are we not updating it? We're updating it right here. Servers, we know it's 3, so it shouldn't. Why is it always -1? Huh. Is it because of the way I wrote my tests? Like, I don't get it. What is this music? Okay. We cycle. Like, the only reason why it would be -1 every time is it's entering here or here. I mean, I'll just, I guess, put like a print line here for whatever reason, but I just don't think. Error, server list empty. Because, oh, if we go to the test, maybe that runs first. This is not the right test. We require no error first, and then we do this. Oh, didn't want to do that. Let me run the test again. Can I put you back there? Thanks. Go test -verbose -race package algorithm. Go test that. There we go. So error server list empty for the first one. That's okay. 3 is the length. 3 is the length. Why is it -1 every time? Is it because of the way I set my test? Like what the hell?
What we do here is go back.
Okay, let me just do it. We know it returns 0, but is the actual like inside counters 0? We're gonna do assert. I mean, just like print it. Format.println. We're gonna print rr.perServer. Per server. Okay. Per server is 0. So why is it back to -1? Ah, what's happening? Round robin. Okay. Is it because of the mutex that it's not being updated? I guess here just format the print line. Just print the curve server. inside function. Inside function 0, 0, 0. But -1 again here. Okay, wait. Uh, 34. So current server, it says that it's 0. Inside the function, it says that it starts at 0. And then it returns 0. It doesn't return whatever it needs to return. Per server, length of servers. Oh, it only cycles when it's -1 or when the health is false, otherwise it doesn't cycle it. How did I not see this? Oh my god. Okay. Do that. Do that. Do that. We just want to cycle every time? We want to cycle once and then keep repeating it until we find a healthy one. So if it equals -1, yeah, the whole reason why I want to do that is so this doesn't fail, but that means that it's only... So, well, the current server or it's false. Otherwise it just doesn't cycle. See, the problem is here it starts at -1. I needed to get the next one, but I can't check here. But we don't want it to cycle only when it's unhealthy. Okay, so this is fine. It should fetch the next one once. This should be like a do while loop. So it should fetch the next one once. It should do this once. And then if the health of the server is true, it doesn't enter this. Otherwise, it just returns it. So if it's not true, it just keeps cycling. And then here we can come into the problem with the tries, where like if none of them are healthy, then it's just gonna keep cycling and cycling and cycling. So we need to create like a tries here. We create a tries here that is equal to a length of the servers. We do the first try, and then we do tries minus equals 1. And then on each try we do that. So while we still have tries and right? Oh, or actually no, now we see health tries. So here we reduce it by 1 if tries is less than or equal to 0. Return -1 errors dot new, no healthy servers available. We do the first try. If that's the only possible one we could try, then there's no healthy servers available. Otherwise, we keep trying servers until we find a healthy one, or we run out of servers. We should add this as a test, actually. Okay, wait, let's see. It passed. Okay. So it passed now. I'm gonna remove all the prints. In I think I can delete this. Maybe not. No. We go to test, and then format. No prints here. No prints here, and then we go to. This is server.test. I should go to algorithm test. Format. Do that. And then round robin formats. Okay. So one of the servers unhealthy, server list shrunk. I should add a test here that's test no healthy servers. So we do here server list shrunk. Maybe let's do this one, that one last. One of the servers unhealthy, no healthy servers. So we create our new round robin. We make server list 0.set health false, and server list 2 set health false. We paste those here and make them true. Again for that. So here all of our servers are false, or all of our healths are false. So then when we do ir equals rr.next of the server list, we should require error, and then yeah, no healthy servers. Okay, does that pass? Yeah, so it does return an error. And just for my sake, I'm just gonna do format.println error. No healthy servers available. Perfect. So we should add this same one to the test weighted round robin. One of the servers unhealthy. No healthy servers. New weighted round robin. We said the health, and then it should be an error as well. Couldn't find a healthy server. No healthy servers, it should be an error, and then we're gonna restore the health here. One, and then this is 2, and then we set these to true. Wait, can I do? Nope. True. True. Okay, we run the test again. FMT imported and not used. Right. Nice. So it passed. I'm gonna finish soon because I'm gonna go watch Fight Club. I don't know if this is a good point to finish. We're missing testing the least connections and resource base, but I should be able to like copy one to the other. Maybe. Okay, I'll set myself like a timer to like finish at 6. That'd be like 20 minutes. And then I'm gonna finish at 6 because then I need to get ready to leave. Okay, well I'm just gonna do however much I can here. So test least connections. I'm gonna copy this, paste it here. Do that. Okay, so let's see. New least connections. So this is gonna let me actually update all of them. Oh. Okay. So now we're doing least connection. So if for least connections, we don't have recurrent servers, so this doesn't apply. If there are no servers in the server list, we have an error. This test is gonna be different. No healthy servers. This one's good. No healthy servers. We just set. Oh, actually, we're gonna have these 3 servers. Maybe let's do them in order. So all servers are healthy, and we'll just and like some arbitrary order. And arbitrary connections. So here we're gonna say that server list 1 set the connections, the add connection. Actually, we're just gonna say that stats. Oh, we can't do this because we're not in server. Okay, so we'll add for range 3 server list 1 dot add connection, then for range 2 we add them to 2. So the order should be 0, 3, 2 in order of connections. 0, 2, 1, sorry. 0, 2, 1. Maybe let's just do this just in case. We'll just add 5 connections to the first one. So now the order should be 2, 1, 0. No, I kind of want it to be 1, 2, 0. So let's do 4. Yeah, so now 1, 2, 0. And now it should. So if we scheduled the next, and it should give me 1. Then let's add another connection. It should give me 1. Let's add another 2 connections to 1, and then it should give me 2. These are like weird values. let's just do them one apart from each other. So 1, 3, and 5. So we schedule the first one, it gives me 1. Now I'm gonna, for range 3, so it's gonna add 3 more connections, so it's gonna go to 4 connections. It's gonna get to 4 connections, and then this should give me 2. And then for the last one, they're both at 4, so they're at 4 and 3. So we add like 5 more connections to both of them. So we add 5 connections to 1 and 2, and that should give me that it returns 0 here. Okay. All servers are healthy at arbitrary connections. One of the servers unhealthy. So now in this same case, now instead of returning... Okay, so let me do the count. This one is gonna be 1, 3, and 5. Then 4, 3, and 5. And then 9, 8, and 5. 9, 8, and 5. So it should go to 2 after we make it unhealthy. So let's make server 0 unhealthy. I should do these independently, not trusting that like the ones above. Nah, because you would address them from top to bottom anyway. Or at least that's how I would do it. So yeah, it's fine. We just do this test assuming the previous one passed in the correct way. So here, one of the servers unhealthy, we're gonna make 0 unhealthy. And if I do next, it should give me server 2. Right? Because this one would be 8. No healthy servers. It's the same. All servers are healthy and variable weights. This doesn't really help for anything. Server to be repeated becomes unhealthy. Not a valid test for like what we're doing. Server list shrunk. Shouldn't matter, because it recalculates, so this one doesn't apply either. Okay, I got 12 minutes on the clock. Are there other tests? I mean, let's go look at the code. What is it, least connections? So the way this works, don't print this out. The way this works is server stats, append server stats. So we get all the server info, we sort it, and then we pick the earliest one as long as it's healthy. So if there's no things in the no servers available, we should return an error. We should return the one with the least connections, even if they update. If one of the server becomes unhealthy, like one of the servers is unhealthy, it should return the next one. And if there's no healthy servers, it should give me an error. So yeah, this is pretty good coverage for the test, I'd say. We can do pretty much the same for this. but instead of least connections, it's gonna be new resource based. We do this same thing. We append them, and then here we can just say server list 1 dot set CPU usage. This is the one that's gonna have the least. So let's say 0.1. Server list 2 dot CPU usage, the second least, 0.4, and server list 0 CPU usage is gonna go 0.7. That simulates that. We should get one first, then we make one 0.5, so it should give us 2 next. And then we make both of them bigger than the other. Here we do set CPU usage to 0.8 and let's say 0.9. For 1 and 2, so now it should return 0. One of the servers unhealthy, instead of returning 0, it should return 2, so let's reverse this actually. And if no healthy servers, we get an error. Okay, let's try it out. Log imported, build failed. What package is this? Least connections that go. Fail. Okay. That's good though, because we figure out we have a problem. In 233, no healthy servers, it didn't return an error. What did it return? True. We set the health of all of them too. I would like to know what you what you gave me here. Index returned. Index returned 1. Oh. Same with this one right here. Failed, test least connections. Panic, runtime error, index out of range with length 3, recover, repanicked. Is there a 3 here? Testing the Go algorithm in 232 was the error. Okay. And then it came from least connections.go 43. Right here, pick server. Oh. Right, if there's no healthy servers, it should return an error. I don't have that here. So right here, if pick server is bigger than or equal to len of servers, return -1 errors dot new no healthy servers. See, this is what we need to test. We can find these easier. I probably have the same error for least connections. This is least connections for resource. Okay, if pick server is bigger than or equal to len of server stats, I guess. Return -1 errors dot new. Let me go back. No healthy servers. Server stats. Okay. All passed. Perfect. Here we can get rid of this, and then we go up the top. Let's go. So algorithm tests work. What happens if I go test minus v minus race everything in package? Oh, I have to test them individually. What if I just go test -v minus race? Does it taste the whole project? Let me figure that out, because I'm not writing any more code. I think I'm done. But how to run all unit tests in a module in Go? So go tests minus verbose minus race. Okay. Nice. So what have we done today? Okay, we just do that, and then we say create unit tests for algorithm and server package. Next, create unit tests for what are the other packages we have remaining? For Docker and load balancer. Oh yeah, this is the main one. For Docker and load balancer packages. Perfect. Okay, so today I'm gonna close out because I have to get ready to leave, and I've already streamed for 4 hours. Damn, this is the longest stream so far. So today what we did was we created unit tests. We created unit tests for. Actually, I'm missing a unit test for algorithm. I can do that another time. We created unit tests for the server and the algorithm packages. The server package basically defines how how we store our servers, how our load balancer stores our servers, and like keeps track of them, the connections, the CPU usage, the weights, and all that sort of stuff. So we created unit tests for that, and then we also created unit tests for our algorithms. So our 4 algorithms: round robin, weighted, round robin, least connections, and resource based. We created tests for every single one of those as well. We still have to create tests for the other 2 packages, which are the Docker package, which I feel like it's gonna be pretty simple, and the load balancer package, which is our biggest one. So that's the one that's gonna take the most time. And I also should write a unit test for concurrency for the algorithms, but I'll do that next time. I just try to remember. But yeah, anyway, thank you everybody for joining today. I hope you enjoyed me hitting my head against the wall and like programming this load balancer and test. I'm really enjoying this process because I haven't done a lot of testing and writing unit tests, and I know it's a little bit tedious, but it's very necessary when you're writing production ready systems. So I'm very glad I'm doing this and getting practice in how to do it in Go. But anyway, thank you everyone for joining today, and I'll